Alright, today's lesson is going to be on rational functions. Rational functions are functions with polynomials both in the numerator and in the denominator. Alright, the first thing we need to know is what is the degree of this function. The degree is the highest exponent in the polynomial, so in this case, this is going to be our degree. So 3 is going to be our degree. The leading coefficient is whatever the highest exponent is, or whatever the highest degree is. The leading coefficient, the number in front, is the leading coefficient. So that is going to be 3. Alright, so we're going to need to know this in order to understand the next part. So there are 3 types of rational functions. The first type, which we're going to go over, is when the degree on top is less than the degree on the bottom. Right? So for instance here, there really is no degree. The degree on the bottom is 1. Right? So therefore, this matches this description. Alright? In order to solve these, we need to find the asymptotes first. Alright? In this type 1, when the degree on top is less than the degree on the bottom, your horizontal asymptote is always going to be y equals 0. Alright? Y equals 0, you don't have to do anything else. That's it. Alright? The vertical asymptote, however, that's when you take the bottom and you set that equal to 0. So x equals 0. We don't really have to solve x is just 0. So the vertical asymptote is x equals 0. Alright, so what's going on in this is that, hopefully you guys remember from last year, that there is a horizontal and vertical asymptote at x equals 0 and y equals 0. So if I were to do this, there's a horizontal asymptote right there, and then a vertical asymptote right here. So you don't know what the graph looks like. You can always put it into y equals in your calculator and then graph it. The graph of this actually looks something like that, right? And remember, the asymptote is the line where your function will never ever cross. So it will never ever cross this horizontal line, and never ever cross this horizontal line. All right. So the hardest thing about these functions is finding the asymptote. Once you do that, you can graph it. Let's look at another example. So we have something down here: x plus 3 over x squared minus x minus 6. This also matches the description on top. X has a exponent of 1. This one has a exponent of 2. So the degree on the bottom is higher than the degree on top, or is more than the degree on top. The horizontal asymptote for this, again, you don't have to do anything, is just y equals 0. The vertical asymptote, you take the bottom, the denominator, and set that equal to 0 and solve for x. Alright, so say you forgot how to do this. Remember, you could always go to the calculator, graph it, and then remember second trace, and then find the zeros. Alright? So remember that you can do that. Or since this one is pretty easy to factor, we can factor this out, write our ass cheeks out. We have x on this left ass cheek, we have minus 3. On this right ass cheek, we would have plus 2. Right? So you take the left ass cheek, set it equal to 0, we have x equals 3. You take the right ass cheek, set that equal to 0, x equals negative 2. So your vertical asymptote we have at x equals 3 and x equals negative 2. So what does that mean? If we were to sketch this, we have a horizontal asymptote at y equals 0. We have a vertical asymptote at x equals 3. So let's say this is 3. Alright, 1, 2, 3. And 1, 2 at negative 2. Negative 2. So these are the asymptotes for this problem. And that's essentially what we're trying to find. Everything else you can basically graph it and then see where the graph is going. Alright, so let's look at type 2. So for type 2, the degree on top equals the degree on the bottom. Here, this is a 1, this is also 1. They're both equal, matches type 2. The horizontal asymptote for this time is y equals a over b. A is going to be the leading coefficient of the top part. So in this case, a would be 2. So we have y equals a over b. A is going to be 2. And b is going to be the leading coefficient of the bottom, which in this case is going to be a 1. So 2 over 1, that's going to be just 2. Alright, so y equals 2 is our horizontal asymptote. Vertical asymptote, again, all you got to do is set the bottom equal to 0. So x minus 4 equals 0, x equals 4. That is your answer. These are your two asymptotes, that and that. Once you guys know that, again, you can plug this in, graph it, and see where the numbers go. Let's look at another example down here. X squared minus 7x plus 6 divided by x squared minus 4. Again, both of these exponents or degrees are the same. Then we're going to take our equation y equals a over b. A is going to be the front leading coefficient, which is 1. B is going to be the front leading coefficient on the bottom, which is also 1. So this is just going to be y equals 1. Alright? The vertical asymptote, again, take the bottom, set that equal to 0. X squared minus 4 equals 0. I forgot how to factor. Graph it. Find the zeros. You can do it that way. Or in this case, we can add 4. We can add 4 here. X squared equals 4. Square root, x equals plus minus 2. So don't forget that plus minus 2, because when you square a negative number, it also gives you 4. Do not forget that. So your vertical asymptote is going to be at x equals 2 and at x equals negative 2. Alright? So the last one is probably the most confusing, the hardest one. This is when the degree on top is bigger or greater than the degree on the bottom. Alright, so in this case, 2 is bigger than 1, fits this case. The first thing I want you guys to do is try to factor it out. Alright? Try to see if you can cancel stuff out after factoring. If not, we're going to go to the second case. Alright, so this top part, if we factored this out, this would be x minus 3, x plus 2, just like we saw before. Alright, x minus 3 can't really factor, so we're just going to leave it x minus 3. So right here, in this case, we can cancel something out. We can cancel the x minus 3's like that, and then that becomes x plus 2. So what we did, we took this rational function, simplified it, and now we have this. So this is actually a linear equation, right? So it's going to look like a straight line. However, the important thing on this part is you take the bottom and you set that equal to 0, or sorry, set x minus 3 equals 0. Set that equal to 0, x equals 3. What this means is that this is a hole. So remember back in the quadratics or the one of the worksheets, we had like a hole, and we didn't, it was like domain and range. We had a hole there. You didn't count that number. It goes to that number but never touches that number. Same concept here. If we had a graph, so we start at 2, we go up 1, right 1, blah blah blah, looks like that, right? However, at x equals 1, 2, 3, right here, there is a little hole like that. So it's all of these numbers on the line and then skips that 3 right here and then keeps on going. So that's what this is telling you. That is the hole right there. If you can factor it out. This is your linear equation. However, the bottom denominator becomes a hole. Alright, set that equal to 0. That's where your hole is. Alright, don't forget that. Case number 2. We can't factor it out. Alright, there's no way of factoring it out. So what we're going to do is take the denominator, divide it into the numerator, right? So one way you can do long division, you can do x and then x squared minus 4x plus 3. Or in this case, since the bottom polynomial is just by itself, we can take each term and then divide it like that. Alright? So x squared divided by 2, or x, sorry, plus or minus 4x divided by x plus 3x, or 3 over x, sorry. Alright? If we were to simplify this, one of the x's cancel out, so we just have an x. These x's cancel out, so we have a 4. You can't really do anything right here, so we're just going to leave that right there. Alright? Now, we can't factor it out. We divided it. We simplified it. We have x minus 4 plus 3 over x, right? This is basically your remainder. Alright? So don't do anything with that right now. This is your asymptote. I know it's not x equals 0 or y equals 0 or whatever like that. This is actually, again, a linear equation. So it's going to be a line. What that means is at x minus 4, as in y equals x minus 4, that's where your slant is going to be. So minus 4, it's going to look something like that. That's where your slant's going to be. All right, your graphs are going to look crazy. It's going to look something like, so it's going to look something like this. Something like that. All right, and again, you can see this when you graph it. All right, so just remember there's 3 types. The third type is probably the most confusing to understand, but again, you'll have some practice problems to try this and learn this. All right. Please write all this stuff down because it is handy when you go to the questions and you don't know what it is. And if you look at degree on top, degree on bottom, and see which type it is, it's a lot easier to solve it rather than trying to figure it out. All right? So write all this stuff down and we'll go over some in class.